Very good morning to all of you now. Please pay attention. Okay. Students who are attending online, I have kept your paper in the class only. Corrected paper of last test. Okay. We have already started with halogen derivative. We have done two class of halogen derivative. Okay. We have done the classification, monohalogen, then dihalogen, trihalogen. Remember, beta? If one hydrogen it is mono, two then it is di, okay, three then tri, four hydrogen are replaced by four halogen, then it is tetra. Then we have studied what is primary. When my halogen is attached to carbon which is further attached to one carbon, then it is known as what? Primary. When my halogen is attached to carbon which is further attached to two carbon, then it is known as secondary. When my halogen is attached to carbon which is further attached to three, then it is known as tertiary. Okay, then we did IUPAC classification and we started with the preparation. Now, beta, before doing preparation again, I am telling you again and again. Okay, whenever listen carefully, this is very, very important. Hello, this is very, very important. Now, whenever in reaction, suppose this is general representation. If hydrogen is replaced by a function of by chlorine, generally by what? Chlorine. And on arrow, if it is written UV light or diffuse sunlight, okay, then it is always which substitution? Free radical substitution. Then it will be always what, beta? Free radical substitution. Free radical substitution. तूने टेस्ट नहीं दिया था ना इलोनी? Okay. Whenever, then beta, what we studied, whenever, this was our first part, then whenever hydrogen is replaced by directly a new functional group, then it is which substitution? Electrophilic substitution. Electrophilic substitution. This is very, very important. This you should know because this we are going to study throughout today. And third, whenever a functional group, Ashika beta, look here, whenever a functional group is replaced by new functional group, then it is going to be which substitution? Nucleophilic substitution. Then it is going to be what? Nucleophilic substitution. Nucleophilic substitution. Whenever hydrogen is replaced by chlorine, and if there is UV light or diffuse sunlight, then it is free radical substitution. Whenever hydrogen is replaced by a new functional group, okay, and UV light and nothing is written, then it is going to be what? Electrophilic substitution. Whenever a functional group is replaced by a new functional group, then it is what, beta? Okay, chalo, give me example, beta. Chalo, suppose I am giving you this reaction. Now this is my methane, hydrogen, and I have written here chlorine, UV light. Now tell me which mechanism it will be. Tell me, chlorine has come. Very good. Free radical. Suppose now this is my methane. I have done some reaction with the bromine. Okay, and I got CH3Br. So hydrogen is replaced by what? Tell me. By functional group or not? Tell me. So it will be which one? Hey, shut up, man. What is this? Hydrogen is replaced by a functional group. Then it is what? Electrophilic. Okay. Yeah, very good. Now, whenever, okay, I have written this particular reaction. Hello, look here. And I have written some reagent and I got here this one. So now tell me what is replaced by what? Functional group is replaced by functional group or hydrogen is replaced by hydrogen. Functional group is replaced by new functional group. Therefore, it is going to be which reaction? Itna dimag mein gaya. Okay, all of you, I hope all of you are getting it. Keep this in mind. This is very, very important. If you want, you have, just remember these three things. These are very important things because we are going to do this in all the reaction. Now, beta, if you see, have you seen my notes, beta? I have given you the notes. This is in our book too, huh? This chapter which I am doing. You want to take? Yeah, take it. Take it. Which one? I gave you. Oh, sorry. I give you right now. Hey, all of you got this question bank also, na? Give me the beta booklet to you. Okay. So this is very important, beta. This, if you will keep in mind, most of the things will become very easy for you. Now let us go to the next part. Hey, hello. When first, beta, you have to study from the, whenever you do reaction, you'll study from my colorful notes which I have given. That is only for reaction and no theories inside that. Now we did preparation. Now how to read, So if you see in my this notes, I have given a flow chart at the end. Look, I'll just show you. Wait, I'll just show you. No, not in this. Wait. What happened? Yeah, this is. Oh my God. Oh, sorry. It got hanged, man. Okay, yeah, okay. Something is going behind. What is happening there? Wait, no, beta. Something went wrong. I don't know. No, I'll just show you it. Okay. All of you, if you the printed notes which I given, that white color, okay, 2 booklet I have given you. In that, the book number 2. This, no, this was given very long back. Okay, everybody has got this book. And this printed white color book. So now, hey, see how luck. Pay attention. Now, whenever we do preparation, beta, we will always study. I have given flowchart at the end or in all those books, beta. Flowchart is very important. Now, how we have to study, beta? We have studied the first 3 method we did, right? First, we did preparation. First, we took what, beta? Alkane, right? Then we took chlorine. Remember, UV light. And what you got, beta? Alkyl halide. I mean, alkyl chloride. So this is our first method of preparation. Then we took alkane. And then what we added? Bromine in presence of AlBr3. What was the role of AlBr3? It helps to generate electrophile. Okay, right? We got alkyl bromide. This is how you should study. And can I add directly iodine? No, because reaction becomes reversible. So we use a strong, which agent? Oxidizing agents. Okay, and you get this. So this is the first method of preparation which we did. Remember? Then today we are going to continue with the remaining method. Are you getting it? So look, Ryan, you were not there last class, right? Okay, but did you see the recording? No? Very quiet. You have to see it. Look. Yeah. Yeah, it is in the group, man. I have written all the lecture number HDA. Now let it be. Okay. Now look at first we did preparation of alkyl halide from alkane. Look, if I take alkane and if I take chlorine, UV light, what you get? Alkyl chloride. So have you received these colorful notes or not? Yeah. Okay. This color one. So where it is? Not what, man? You have to bring that. Okay, here hydrogen is replaced by what? Tell me. And what is there, beta? UV light is there. Last class we gave it. Last class even there, na? I thought the other book. Shut up. Okay, yeah. Page number 2. Now come to page A. Hydrogen is replaced by chlorine and UV light is written. So it was which reaction, beta? Free radical. I made you write this. देखो जिसने लिखा है, all of you have written this or not? Free radical substitution. Clear? Now in methane, there are 4 hydrogens. So reaction will not stop at 1. Then in first step, 1 chlorine will be, hydrogen will be replaced. Then in second 2, then 3, and then 4. So it is free radical substitution. Why this is not the best method? Because in a container, I'll get mixture of all. Monohalogen, di, tri, and tetra. So this is not the good method. So then we go to this reaction. Right now, tell me, hydrogen is replaced by functional group or not? Tell me. On arrow, have they written UV light? No, na. So it is which substitution? Electrophilic substitution. Remember electrophilic? Acha. I have made you write this also. And who is the electrophile? Electrophile is what? Br plus bromonium. In last, please, those who have missed out last class, please watch it. I have explained everything. What is electrophile, nucleophile, free radical, stability. Okay. Clear. What was the role of AlBr3? It helps to generate electrophile. I told you what is the entire mechanism also. Okay. Chalo. Shall we go to the next part? Hello. Now, when I used to do direct iodination was not possible. Why direct iodination was not possible? Because if I directly add iodine, the reaction becomes reversible. Why it becomes reversible? Because of HI. HI is bond length is big. As you go down the group, if it is beta HCl, HBr, and HI. So who's the biggest beta? This bond is bigger, na? So it is unstable. It will break and it will make the reaction reverse. Due to what, beta? This is HI act as what? Strong reducing agent. In the colorful notes, beta, if there is a place here, you can write this. Direct iodination is not possible. I have given in my printed notes, but I want you to write this there in the color notes. Here, just before this iodination. Therefore, what we have to use? Therefore, we use, look, Ryan, what we have used here? I have added iodine, but I have added this also or not? So this act as an oxidizing agent. This act as what? And in the product side, can you see now, is HIF being formed here? So no, reaction will not become reversible. Okay? Clear? लखने पढ़ाई करो हाँ बेटा अच्छे से तेरा पोर्टल तूने रजिस्टर किया ला हाँ तो आज करके जाना यहाँ पे all of you were what happened what was your problem the test were you able to see the test
मी त्यांच्या सोबत जातो
done now let us go to the next part hello yeah so we use strong oxidizing agent so look how to read first you will see reaction from here then beta I have given flow chart make a flow chart in your own handwriting and stick it and every day you have to see it once beta then only because organic chemistry you won't remember it is highly volatile okay yeah I'm not joking yeah seriously so that you do you have to make the flow chart I have already given the flow chart but if you write with your hand then it will be very much helpful for each chapter you can make one okay and already it is given in the notes all chapters behind if you see na in my that other notes printed notes which I have given there is a flow chart preparation on one side and chemical reaction on the other side okay let us go to the next part now today we are going to go ahead now I think we have not done this all right yeah look beta we have done this hello and whenever there is an opportunity for formation look at if anybody get a chance to become for free radical and electrophile I'm talking about what beta free radical and carbocation sorry free radical and cation so if they get opportunity in life they will try to prefer to what they will prefer to become primary secondary or tertiary tell me they will always try to prefer tertiary suppose in a reaction I'm getting two possibility I'm getting one secondary compound and one tertiary so it will always prefer to become but if I'm getting primary and secondary then it will try to become if I'm getting primary and tertiary then it will become so tertiary is most stable clear okay now listen here Free radical, this is for free radical and tertiary carbocation. Why it is more stable? Look, beta, I'll just teach you, beta. Look here, all of you. Now, suppose this is my primary. Hello. Suppose the carbocation means this is my carbon and it is having some positive charge. Ryan, beta, can you see this is attached to further one carbon? So it is what? Primary. Primary carbocation. Now look here. This is which carbocation? Tell me. Nereicite is attached to how much? Tell me. 2 carbon, na? So it is secondary. Now here, Miranda, you see here. It is attached to how much, beta? And this carbon having positive charge is that. This is tertiary. Now, since you are not there in 11, but I'll just tell you, alkyl group shows, alkyl group repels electron. Alkyl group, yeah, that is why alkyl group repels electron, because in alkyl group, if you see, there are how many hydrogen? 4 like this, 4 bonds. So it is which hybridized? sp3. Percentage of S character is only 25. Okay, electronegativity is directly proportional to percentage of S characters. So it has the lowest S characters. Okay, so it has the least electronegativity. So it will what generally, it will repel the electron. It will. So this property of repelling the electron is known as plus I effect. Which effect? Plus I. Okay. Now look, what is this I effect? I'll tell you. If there are two persons and there is a tug of war, where this electron pair will shift towards X or towards Y, who's more powerful here? So the one who pulls electron toward itself, we call it as which effect it shows? Minus I effect. The one who give away the electron, then it shows which effect? Plus I. So alkyl group will generally, who all I effect? Alkyl group. All alkyl group will show plus I effect. Who will show minus I effect? Most electronegative element, like halogen. All halogen are electronegative, right, beta? So here what will happen? Tell me. Here in primary, can you see this was primary? This is one alkyl group, so it will repel electron only once. This will repel electron how many times? 2 times. This will repel how much? Now, what is the rule for stability? Lower the charge, higher the stability. Lower the charge. Now, on all this, there was how much? What was the charge initially? +1, +1, +1, right, beta? So now let us say if this is repelling electron, what will happen to this plus charge? It will decrease, na? So it will decrease. Here, how many of them are repelling the electron? 2 times. So they are throwing 2 negative charge on this. So this positive charge will reduce. Here, how many of them are repelling the electron on this? 3. So this positive charge will be the least. Look here, the positive charge is more because only one time electron is coming on this. Here it is little less. Why? Because 2 of them are. Here it is the least. Which one has the least charge? This fellow. Lower the charge, higher the stability. Is this clear? Lower the charge. Suppose here there was, let us say, I'm just telling 10 positive charge. Okay. Here now, what is happening? One electron is being thrown on this. So it will become how much, beta? +9. In the beginning, let us say all of them was having +10 charge. Now, how many electron plus I? It will become +8. Here, how much it will be? 3. So it will be how much? So this fellow has the lowest charge or not? Tell me. Lower the charge, higher the stability. Hey, Tiloda, get up, man. Clear? So now you have to tell me, hello. Now in this reaction, I was doing chlorination. Ryan, where all my chlorine could have gone? It could have gone here on first carbon, or it could have gone on which carbon? This. This is primary, and this is what? So which one is more stable, primary or secondary? Just now we studied primary, secondary, and tertiary. The first is tertiary, but there is no option for tertiary. So there are 2 possibilities, primary and secondary. So which one it will try to become? Therefore, our secondary is major product. Understood? Clear? And primary will be also formed, but that will be what? Minor. That will be. Now let us go to the next part, beta. We have done all this in my printed notes. We did na bromination. It is AlBr3 helps to generate what? Electrophile. Okay, direct iodination is not possible. Why? Look, I have given the explanation also. Can you see the HI bond length is bigger? Yeah. The handwritten printed notes, everything I have given. Okay. So we use strong oxidizing agent. Now we are going to start with the very important part. We are going to prepare from what? Alkene. We have done first preparation. Now we are going to prepare from what? Alkene. And this is very, very important. Hello. Now, alkene are of two types, symmetrical and unsymmetrical. First, I want you to understand what is symmetrical. Tiloda, now you tell me, beta, look, this is double bond, right? On the left hand side and right hand side, do you see the same atoms? So it is symmetrical or unsymmetrical? Here also on the left hand side and right hand side, you see it is same or different? So it is symmetrical. Are you getting it? Now here I want you to see on the left hand side and right hand side, do we have same atoms across the double bond? No. So it is unsymmetrical. It is what? So first we are going to go for the symmetrical. What is the heading, beta? Hydrohalogenation. So what all thing I am going to add? Hydrogen as well as halogen. Kunal, beta, now look here. This is my double bond alkene. So I am adding, look, can you see hydrogen is positive and halogen is negative. So I am adding
आगे
two.
की बात की अभी
It could have gone. Please. They have recorded ना बेटा? हाँ? Recording है?
Yes, sir.
It's on ना? हाँ. It is recording. Yeah. Otherwise, this would have not come. Okay. Now, anyways, now look. If I add, hey, Konark, look here. If my chlorine could have gone either here or it could have gone here. But beta, both are same carbon only, na first carbon. So will the name change? No. So here I can add them directly. No rule to be followed. Look, Miranda, look here. If chlorine will go here, it will become again ethyl chloride. Or if it go here, then also it will become on first carbon only. Na? So no rule to be followed. So what will happen? This double bond will break. And one hydrogen will go here and Cl will go. So it has become CH3. And what is this beta? Ethyl chloride. Ethyl. So, both hydrogen and halogen has been added. Therefore, we call it as hydrohalogenation. If I take HBr and ethene, again I'll get ethyl bromide. If I take HI and ethene, then what I'll get, beta? Ethyl iodide. No rule, direct addition. Ryan, you look here. Arey, Heath, beta, yahan pe dekh. Now here also it is symmetrical or not, tell me. Now look, addition will always happen across the double bond. It will not happen here and here because this double bond will break and two bonds will be formed here. So one chlorine could have gone here or it could have gone here. But both are second carbon only or not, tell me. This is also my second carbon and this is also my clear. So no rule to be followed. Okay, any difficulty till here? So you get here 2-chlorobutane. And here it has become CH2 double bond has disappeared. If I add iodine, then again same thing I'll get. But here this is very challenging now. Here if you see, if I take propene, unsymmetrical alkene, if I take what? Unsymmetrical alkene. Look here, this is CH3CH. Now tell me. Hey Dhairya, now you only tell me, I want to add hydrogen and chlorine. Now chlorine is negative. If I add chlorine here, then it is which carbon? Primary or secondary? This is further that one. And if it goes here, then what it will become? Here if I add, then it becomes 1-chloro. And if I add here, it becomes. And now I explain you. If in life, if any compounds get opportunity to become primary, secondary, tertiary, first it will try to become tertiary. But is there any possibility of tertiary here? So what it will try to become? Secondary or primary? Why secondary? Because electrophile, secondary carbocation is more stable. Clear? Any difficulty till here? And one more thing I wanted to tell you, beta, whenever there is a carbon-carbon double bond, and if any group is getting added to it, suppose if I'm adding XY, and if it becomes like this, one place X and one place Y, then it is always electrophilic addition. We have studied unsaturated compound undergo which reaction? Addition reaction. So it is electrophilic. Whenever there is a carbon-carbon double bond and if peroxide and anything is not written, it will be always which addition? Electrophilic. Whenever there is a carbon-carbon double bond, if there is no peroxide, then it is always what? Electrophilic addition. So now you only tell me here. Look, we want to study the rule, but Markovnikov gave one rule. What rule he said? If this is my negative, where it will go? This will be my major product or not? Tell me. And on this carbon, how many hydrogen are there only? And on this, if it would have gone here, Ryan, look here. If it would have gone here, how many hydrogen were there? So what Markovnikov said that whenever an unsymmetrical alkene unsymmetrical is reacted with unsymmetrical reagent. Why this reagent is called as unsymmetrical? Because this is positive and this is. Then the negative part of my reagent will go to the carbon having less hydrogen or more hydrogen. Understood? Why he said less? Because less one is less. Why he used this word less hydrogen? Because that will form secondary carbocation. That is the main reason. And secondary carbocation is more stable. Is this clear? Now look, I have given very nicely in the notes. Look here. Ryan, look here. Come on. Okay, here this is what? Propene. And can you see this is unsymmetrical reagent? Okay, now here, this fellow is having how many hydrogen? One hydrogen. This fellow is having how many hydrogen? Hey, what? One man? Hydrogens. This fellow is having two hydrogen. Across the double bond only will see. You will not see this carbon. Okay, so now this is my negative part or not? Tell me. So negative part of the reagent will go to the carbon. Look, I have written here only. Will go to the carbon having. This is your mark point. But what was the logic behind this? Because this will form what? Which carbon beta? Secondary. And this will form. And secondary is always the major. So this is Markovnikov rule. Achha, and this addition is which addition? Whenever carbon-carbon double bond and this addition. So this addition is which addition? Right here. Electrophilic addition. Write it. Electrophilic addition. Ye Markovnikov rule hai na, there you will write electrophilic. Whenever carbon-carbon double bond is there and if peroxide is not written, then it is always going to be what? Electrophilic addition. Clear? And in life, if there is an opportunity to form alkyl halide or alkyl alcohol, primary, secondary, or tertiary, first it will prefer to become tertiary. If not tertiary, then secondary, right? And it will be always the major product. What is the logic behind it? Because secondary carbocation is more stable than primary. Is this clear? Okay. Now let us go to the next part. युवराज कहाँ पे है? युवराज, ऐसा ये लोग आएगा नहीं, कुछ होगा नहीं. Hey, Ethan, man, when you are going to come? You have not taken single notes from here and you are not coming also and attending also. What, man? हाँ? आया था बीच में एक दो बार. Okay, anyways, चलो ना, let us go. Hello. Hello. Now, all these notes will be useful to you, beta. So look here, how many possibility I got here? Look, this is why I have written here major. Have you understood? Because this is secondary and the primary will be minor. Clear? Yeah. Now let us go to, hey, pay attention here. क्या देख रहा है तू? What? Huh? Now look here. Come on here, Nerissa. Look here. This is HBr. This is symmetrical or unsymmetrical? First tell me. Say unsymmetrical. Now look, this is the double bond. This fellow is having how many hydrogen? This fellow is carrying how many hydrogen? Zero. No hydrogen. Because this is attached to carbon, man. Okay. So what Markovnikov will say now, it is answer. So where my negative part should go? So carbon carrying less hydrogen. So it will go here. And look, now if you even if you don't remember Markovnikov, we can do directly. If there is an opportunity to become primary or secondary, if it would have gone here, it would have become what, beta? Primary. And if it would have gone here, then it will be attached to how many? 3. So it would have become what? Tertiary. So which one is most stable? Tertiary. Are you getting it? So therefore tertiary is the major product. Understood? Clear? Tertiary carbocation is the major product. Chalo. Let us go to the next part. What is your name? Darsh? Nahi kya? Darsh, na? Darsh. Darsh. Okay. Look here. This is now, tell me first of all, it is symmetrical or unsymmetrical? So now where it should go? This fellow is having how many hydrogen? 1. ये मत देख, ये इसका है भाई, ये ऐसा यहाँ पे अटैच होगा. ये can you see this? So this fellow is having 1 and this fellow is having 2. So negative part will go to the carbon having less. Now I want all of you to see here, whenever we did Markovnikov rule, what was always major product? It was either secondary or tertiary. Will I ever get primary as a major product by using Markovnikov? No, never. No, never. So what we are going to do? Okay, so Markovnikov, look, I have written here, Markovnikov rule. will always give secondary or as major product. As major means it is always secondary and tertiary. So Markovnikov rule will always give you what? Secondary and this you have to keep in mind. It will always give you secondary and tertiary. Is this clear? Okay, we'll never get primary as a major product in Markovnikov. Now, there were two scientists. One name was Kharash and Mayo, or therefore it is also known as Kharash effect. What they did, they carried out the reaction in presence of peroxide and HBr only. HBr, not any alkyl halide. In Markovnikov, I can use any hydrogen halide. I can use HBr, HCl or HI. Look, I have written here. We can use anything. HCl, HBr and HI. But for anti-Markovnikov rule, we have to use only, and please make a correction here. Here, anti word is missing. Anti on the right hand side. Anti, so this will be also anti. Anti-Markovnikov rule is shown by HBr and peroxide. HBr only. If I use HCl, then it will again follow Markovnikov. Okay, it will follow which rule? Anti, make anti here. Okay. Now, what will happen here? What he did? Come on. Again, it is symmetrical or unsymmetrical? Come on, Elon, it is symmetrical or unsymmetrical? Unsymmetrical. But now we are following here. HBr is there and what is there? Peroxide. HBr and peroxide. So whenever HBr and peroxide will be there, we have to follow anti. Markovnikov used to show, used to tell it used to negative part used to go to which one? The carbon having less hydrogen. But here it will go to more. Ulta hai na beta, it is reverse na anti. So it will go to more. So now Divya, tell me here how many hydrogen are here on this? And here how much? And peroxide is written. And you have to see two things. Before applying anti-Markovnikov, peroxide should be there. And HBr should be there. If I don't mention HBr, if I write HCl or HI, then you will follow Markovnikov. So anti-Markovnikov is possible only with HBr and peroxide. So here my negative part will go to the carbon having more. So, this is sodium peroxide. This is also peroxide. I can use benzoyl peroxide also. Peroxide should be there, like this is your benzoyl peroxide. Any peroxide I can use. Clear? And here it will go. So here it will always give you which one? Primary alkyl bromide. I cannot use the word halide. I cannot use the word halide. Why? Because it is not possible with chloride and iodide. So it will be always primary alkyl bromide. So anti-Markovnikov rule will give you. Whenever anti-Markovnikov rule is there, beta, please write here which mechanism it will follow. Free radical addition. What it will follow? Write it. Whenever carbon-carbon double bond is there and if peroxide is written, then it will be always free radical addition. Look, double bond is getting it is getting broke, and what is happening, beta? Addition is taking place or not? Double bond is undergoing cleavage, and beta, what is happening? H and Br is getting added. Are you getting it? Hello? What happened? क्या बे ढक्कन किधर था? युवराज, what man? Where were you? Sleeping or what? Can't attend class? Very important. You will not understand anything in organic. Very important thing I covered. Is this clear, all of you? Now one question should come. So why we have not used HCl and HI? Look, in this, no, let me tell you. We wanted here free radical. Yeah, we wanted here free radical. But if I take HCl, so the bond length is so small that peroxide cannot attack it and it will not generate free radical. HI bond length is so big. HI bond length is so big that it will break on its own and it will form iodine. So who has the ideal size for formation of free radical? HBr. Who has the ideal size? So this is not possible with these two, because it will not help to generate electrophile. Who is generating electrophile? Peroxide is generating the electrophile. Yes. Yeah, HCl. Now look, in this reaction data, we want to generate an free radical. We want to generate a. Okay, so in order to generate free radical, peroxide will react with HCl. But the HCl bond length is so small that peroxide won't be able to break it. So free radical will not be generated. And in HI, the bond length is such a big that it breaks on its own and it will form iodine.
HCl bond is very strong.
It cannot form free radical. HI is very big, so it dissociates to give you directly iodine. And then HBr, HBr has the HBr has the ideal size to generate the electrophile. All this we have done in 11th bit. I have written and I give an explanation for hydrocarbons. Okay, in hydrocarbon we have done this.
HCl breaks it in four.
HCl it won't break. And the HI, yeah, bond length is big and it forms iodine. So no free radical is generated in the first and the last case. HBr has the ideal size to break to form free radical. Okay. All this they won't ask, but this is just for your information. I'm telling you. Okay. So this is ideal for peroxide to attack and form free radical. फ्री रेडिकल ऐसा यहाँ पे फ्री रेडिकल बनेगा बरोबर. ओके, then it will form Markovnikov. Then it will form Markovnikov. So in exam they ask such question. We know on aero they will write peroxide, and just to confuse you, they will write HCl and HI. So generally what students will do, listen, hey, this is very important. Most of the time in exam data, in order to confuse you, what they will do, on aero they will write peroxide, but here they will give you what, HCl or HI. But whenever HCl and HI, even though there is a peroxide, you will follow which rule? Anti-Markovnikov should be followed only and only when there is a peroxide and HBr both. So that is why I have written here below. Can you see this? Here I have written everything, beta. Look here. Here what was missing, I told you, na? Anti. Here look, HBr and peroxide both. And look, anti-Markovnikov will always give you primary alkyl halide, no halide. Why? Bromide, because it is possible only with. Is this clear to all of you? Hey, have you understood this? Now let us go to the next part. Preparation from. Now look, in our flowchart, how you will go about our flowchart, beta? What all things we have done? We have done from alkenes. Hello. There you go. I told you now. I have given flowchart. Don't worry. Now we did from alkene. In alkene, we have two possibilities. First was Markovnikov rule, and then what? It was what, beta? And anti-Markovnikov rule, we have peroxide and all. And it will give you, this Markovnikov will give you secondary or tertiary alkyl halide. And this fellow will give you always primary alkyl bromide. Aisa flowchart you have to make. It is already given. But I want you to make it on your own. हाँ, मैं सब भेज, अरे नोट्स में भी है, मैं फोटो भी भेजूंगा, बस ठीक है. ए उठ रहे, व्हाट मैन. Now we go to the next method, that is from preparation from what? Alcohol. From alcohol. Right? Now alcohol are of three types. Which all alcohol are there, beta? Now I want you to look this. Ashika, now this is my functional group. It is attached to carbon. So it is which alcohol? Primary. Here my OH is the functional group. It is attached to the carbon, which is further attached to how many carbon? Here my OH is alcohol. It is attached to carbon, which is further attached to how many? Now we are going to prepare from alcohol. Alcohol say I want what? Alkyl halide. So OH is replaced by what? Halogen. So functional group is replaced by new functional group. So it is what? Nucleophilic substitution. Anyways, now what we use a reagent for this? We use, I have given you three test tubes. In one there is primary, in one there is secondary, and in one there is what? Tertiary. In all these three, you are going to add Lucas reagent. What you are going to add? Lucas. What is Lucas reagent? Anhydrous zinc chloride. Anhydrous chloride and concentrated HCl. These two are known as what? Lucas. I have given everything. Wait, beta. Look here. Arey baby, look here. Here it is given. Look. Concentrated HCl and ZnCl are called as what? Lucas reagent. Now in this beta, look. What is going to happen? Can you see this? It will disappear. You get water and chlorine will go here or not? Tell me. In all this, same thing is happening or not? Tell me. Concentrated HCl. Okay, now listen carefully. Concentrated HCl सब में concentrated ही रहेगा. Condition will differ. That is what I am trying to say, tell you. Now, suppose this is also used as test for alcohol. This we are going to study in alcohol chapter also, where we are going to study in. Yeah, alcohol is a chapter. Alcohol, phenol, and ether. After that, you have a chapter aldehyde, ketone, and carboxylic acid. After that, you have a chapter amines.
This sort of all the numbers combined only this chapter.
This is only for halogen derivative. What meant? Then what meant what? Look, beta. Again, I am telling you here. Organic chemistry. I'm going to go very slowly. I'm going very slowly. Normally in 3 class, I finish this chapter. For you all, I'm going very, very, very slowly. Yeah. 3 class, I finished this actually. I'm explaining each and everything. I'm doing from the basics. Now, whenever I do this reaction, primary, secondary, and tertiary, in all I added Lucas reagent. If I tell you now in which test tube there is primary, secondary, or tertiary, the one in which when I add Lucas reagent, immediately I get cloudy solution, then it is tertiary. The one in which I add Lucas reagent, and after 10 minutes, if I get cloudy solution, then it is. And the one in which I add Lucas reagent, nothing happens. Then, no, I will see cloudy solution after heating. Then that is primary alcohol. So what do we conclude from this? Between primary, secondary, and tertiary alcohol, who is the most reactive? Immediately, किसमें मिला मुझे? Tertiary is more reactive. So look, therefore, beta, can you see here I have written heat. Here I have written heat. So it is happening. I'm not getting immediate turbidity. Here I'm getting after heating. Here I'll get turbidity after 10 minutes. Here I'll get it immediately. Clear? Look, basically we are interested in preparation of alkyl halide or not. We are getting alkyl halide from what we have prepared from alcohol. Understood? Okay. And this is also used as a test to distinguish between primary, secondary, and what is the order of reactivity for all this reaction now? Look here, beta. What is the order of reactivity I have written here? Which alcohol is more reactive? Okay. If I want to prepare alkyl chloride, I wanted here alkyl chloride. So I used HCl. But if I want alkyl bromide, तो क्या करेंगे? Instead of HCl, what should I use? HBr. What I should use? But problem is what, Vita, I cannot prepare HBr and store in the lab. Why?
Yeah.
No, it breaks again because the bond length is big. Even HI also, I cannot store in the lab and keep it for a longer period of time. So now I want to do the same reaction with what? HBr. But what I will do, beta, I cannot prepare HBr and store. So I will prepare it freshly. I will prepare it during the reaction. Anything which is prepared freshly during the reaction, usko hum log kya kehte hain? What do we call it as? In situ. What we call it as? In situ. What is in situ? Look here. In situ. What is? Look here. In situ. Yeah. In situ. Hello. Listen. This is not related to bio. Yeah.
That is not transported.
I'm not relating it to the bio. We are talking in chemistry. Whenever I mention word in situ means it is freshly prepared during the reaction. Is this clear? Why we have to prepare it freshly? Because I cannot prepare it and store it for a longer period of time. So I want to prepare it. So how I will prepare? Now look, everything is same. Look, beta, here, listen. All these reactions are almost same. What is changing? Instead of chlorine, I have written what? Br. Bus. Are you getting it? But HBr I have to generate in situ. So whenever anything is prepared in situ on arrow, we mention how I got this HBr. NaBr will react with, listen, NaBr will react with H2SO4. And it will generate HBr. Are you getting it? So why I have written this here? Because these two will react among themselves to give you this HBr. Understood? Rest reaction is one and the same. Instead of Cl, you will write what? Br. Very good. Any difficulty till here? Why we have written on the arrow? It is prepared in situ. वहाँ पे circle कर ली in situ. समझा के नहीं? What is in situ man? हाँ, is unstable. Why we have to prepare? Because HBr is unstable. So HBr is prepared freshly by treating. Everything is written. Can you see? In situ. Okay. Clear? तूने देखा ना बेटा, वो तूने क्वेश्चन ही नहीं अटेम्प्ट किया पेपर. Okay. Now beta HI तो it is highly unstable ना बेटा. अरे HI, so HI also I have to prepare what? In. So how I am going to prepare it beta? Look here. I am going to take sodium iodide, or look, I'll write it here. Sodium iodide or potassium with phosphoric acid. Okay. Na2HPO4, and what I'm going to get? HI. Nobody will ask you to write this, but this is just for your understanding. In situ, we are preparing in situ. What? In halogenation, we use HBr, but in halogenation, we use HBr, but with whom? Alkene. Here it is what? So, alcohol है ना बेटा? हाँ, obviously. We use it, obviously. ठीक है? Clear है? Any difficulty till here? What is the order of reactivity here? Tertiary is more reactive than secondary then? Now look, if we want to go to our flow chart, now look beta, here there is no place, huh? So I'm just writing here. Now we prepared it from what beta? Alcohol. Okay, so in alcohol I can use either what beta, tell me? HCl, HBr or HI, right? And it will give me alcohol. If I use HCl, then what? Zinc and Lucas reagent, then I'll get RCl. If I use HBr, then I'll get RBr. And if I use HI, then I'll get alkyl iodide. Clear? There are other ways also from preparing from alcohol. I will use, phosphorus trihalide. Phosphorus. There is another way also from preparing from alcohol by using phosphorus pentachloride. And this is the best method which we are going to use now. Thionyl chloride. Which method? Thionyl chloride is the best method. Okay, so I'll teach you. Wait, one by one. Don't worry. Hello. Look here. I have given in the split form. I have given everything in the split form, so you'll understand better. Now look here. Trisha, can you see here? The heading is what? By preparation from what? Alcohol. Now I'm using what? Phosphorus trihalide. Phosphorus tri. First I'm taking PCl3. Now in exam beta, they will not give you this. They will directly give you this 3ROH. This is the way they will, is written in the book also. 3RCl and what? But I have written purposely in this form. Now you'll understand better. Look, can I write phosphorus trichloride in this way? PCl3. Can I write 3 molecules of alcohol? Now look here. Trisha, can you see this? How many H is here, beta? 1, 2, 3. So H3. How many P is here? 1. And how many O? Now what is remaining? What else is remaining? RCl, RCl, RCl. Now look. So once you see this, you'll remember what is exactly happening. This is known as phosphorus acid. This is known as which acid? Now, PCl3 I can prepare and store in lab.
Phosphoric acid.
No. Phosphoric is H3PO4. This is phosphorus. Sulfurous, sulfuric, nitrous, nitric. Us means one oxygen is less. Okay? Now. Here, can you see beta PCl3 is stable, but PBr3 I cannot store it. Why? Because it will break. Why it will break? Because PBr bromine size is bigger, na? So now what I have to do? मैं PCl3 बना के store कर सकता है man. I can store it, but for PBr3 what I'll have to do? In Syria, I will have to prepare freshly. So therefore, beta, if you see here, I have written on the arrow P plus Br2. Now same reaction, everything will be same. Instead of PCl3, it is going to be what? PBr3. Can you see this? Same thing is happening or not? Tell me. Yeah. Direct. First, we'll add this. Heat it and it will form PBr3. These two react and gives you PBr3. Are you getting it? Same thing will happen with what? Pi3 is highly unstable, right? Pi3 is highly unstable. So again, Pi3 will also be prepared what? Freshly. So look, I have written here. ठीक है ना? Red phosphorus will react to form PbR3. Hey, now I taken what? Maybe Pi3. Look. Any difficulty till here? So we have done PCl3, PbR3 and Pi3 and we are still using alcohol. Now I am going to use what? PCl5. PCl5. Look here. Divyangna. PCl5 किधर गया? Here it is. Hey, see the page number. Huh? Your page number is proper, na, beta? In mine, the page number is up and down. Page number should be 5.
5.
5, na? Yeah, very good. Shh. Look here. Divyangna, can you see this is PCl5? Can I write this in the split form? And we are writing here alcohol. We are doing preparation from alcohol. Now look, this HNCl will react. What will get? HCl. Okay. This R and Cl will go. What will get? What else is remaining now? This PCl3 and this O. So what I get? So look, I have given in the split form so we'll understand better. Clear? This is known as phosphoryl chloride. Nobody is interested in this. We are interested in this. Alkyl chloride. Is this clear? Then you will ask sir question. Sir, why you have not written PBr5 and PI5? PBr5 banega hi nahi. It won't be formed. Why? Because bromine ka size is big. So only 3 bromine can surround phosphorus. 4th and 5th bromine, there will be no place to enter only. Are you getting it? Steric hindrance. We call it as what? Steric. So now, the best method we are going to go for. So these are the example beta. Now what I have done, in example beta, we replace R by alkyl group. Are you getting it? Clear? These are the general reaction. You are supposed to remember the main reaction, general reaction. Example, you can substitute. You can replace R by methyl, ethyl, isopropyl, whatever you want. Now, thionyl chloride or sulfonyl chloride. Thio means sulfur, huh, beta? Thio means sulfur. So we are going to go for thionyl chloride. Which one? Or it is also known as sulfonyl. What is the formula? SOCl2. Hey, can I write this like this? Can I write as thionyl chloride like this? Sulfur form 4 bond, valency of sulfur 4, right, beta? Okay, look here. So I have written thionyl chloride like this is my thionyl chloride. Can you see? Hello. And this is my alcohol. Can I write alcohol this way? I have written in a split form purposely. Now look here, what will happen? Ashika RCl. So you get alkyl halide, HCl then. And what it is here? Can you see SO and O? So SO. But we are interested in this. Hey, why I have used here pyridine? Pyridine is base. Beta, pyridine is base. Okay. Now in this reaction, beta, HCl is formed. Na? So pyridine will neutralize this HCl. Acha, why this is the best method? Can you think of it? Best method. Now in any reaction, beta, whenever I talk it, whether it is the best method, then in product side, you know, I should get the main product only. And remaining byproduct, they should, you know, they should go. I mean, they should be evolved. Now in this case, can you see what was my byproduct? SO2 and SO2 is gas, it will escape from my container. HCl is also gas, it will escape. So what will remain in the container? Only alkyl chloride. In the previous method, yeah, I'll write that, beta. I'll write for you all. Don't worry. H. In the previous case, when I was making alkyl halide, can you see the byproduct? Was it getting evaporated or evolved? No, na. So in my container RI and this both will be there. So to separate them, I have to do again more kharcha, right? Na? So that is not the best. The exam may beta ye aayega, which is the best method. So this is I have written here. Look here. Can you see? Best method. Clear? And I've written also. They escapes. Clear? Now, and I'll just tell you what is the name of this process. Right here, bracket mein. Tarzan's process. What was the name of the scientist? Tarzan nahi bhai, Tarzan. Tarzan's process. Tarzan's process. Okay, beta, you want pyridine, na? Pyridine ऐसा होता है. Look here. This is benzene. Benzene में मैंने nitrogen डाल दिया. Nitrogen पे lone pair होता है. Lone pair donor or Lewis base. This is pyridine. It is a base. ठीक है? What may happen? Sometimes HCl may interfere in the reaction. So this pyridine will absorb this HCl. Okay? Clear? Okay, so we have done preparation from what, beta? Alcohol. From alcohol, what all thing we did? First, we did HCl, HBr, HI. Then PCl3, PBr3, PI3. Then PCl5 only. Why not PBr5, PI? Not possible. Yeah, very good. Then beta we did from best method is which one? SOCl2, thionyl chloride. Clear? Any difficulty till here? Very good, very good. चलो ब्रेक देता रुक जा, पहला ये प्रिपरेशन खत्म करने दे. Okay. Now, beta, we go to the very important. This they ask very frequently in exam. Halogen exchange. What is the name of the method? In halogen exchange means what? A. Remember, beta, in the beginning we have studied. Can we do direct chlorination? Not possible. Fluorination. Direct fluorination. Because reaction of fluorine is highly explosive. So now first time we are going to prepare alkyl fluoride. First time we are going to prepare by alkyl. Acha, the very first method is which one, beta? Finkelstein. It is halogen exchange. What is the name of the method? Finkelstein method. Finkelstein. अच्छा, मैं आपको एक ट्रिक देता बेटा. हाँ क्या? बहुत सब नेम रिएक्शंस बहुत सारे हो गए बेटा. टेंशन मत ले बेटा, आएगा. थोड़ा पेशेंस रखना. ओके. फिंकलस्टन में आप लोग को याद, आप लोग फ्रैंकी खाते हो कि नहीं? फ्रैंकी. तो हाँ, फ्रैंकी इफेक्ट के लिए. लेकिन इसमें भी मैं बताता ना, सुन ना बेबी. फ्रैंकी में क्या आता है ना. तो हियर वी विल प्रिपेयर अल्काइल आयोडाइड. व्हाट वी आर गोइंग टू प्रिपेयर? अल्काइल आयोडाइड इन फिंकल में भी आता है कि नहीं? ये ले भाई, फिंकल में आता है कि नहीं? तो इसमें क्या बनेगा? अल्काइल आयोडाइड. लुक बेटा, अल्काइल आयोडाइड, अल्काइल. Okay, so halogen exchange. Look, I am using alkyl chloride and alkyl. I am making it react with sodium iodide. Now, what is happening? Chlorine is being replaced by iodine or not? Halogen is replaced by halogen. Halogen is replaced by halogen. Right? So, therefore, halogen exchange. And it was studied by which scientist? Finkelstein. Therefore, it is known as Finkelstein reaction. In Finkelstein, which iodide is produced? Finkel में I आता है, याद रहेगा. So, alkyl iodide. Now, here we use dry acetone. What we use here? So, beta, this NaCl which is formed, it will get precipitated in dry acetone. Yeah, obviously. Okay. Is this clear? And on this side, I have taken example. Narissa, look here, I have taken example. Means chlorine is replaced by what? Iodine. Bromine is replaced by? I have just replaced this. Instead of R, I have written example. Are you getting it? कोनार. हाँ, लास्ट रिएक्शन. अभी फिर इसके बाद ब्रेक दे रहा हूँ. इसके बाद ब्रेक. हाँ, नहीं, इसके बाद मैं ब्रेक दे रहा हूँ. नहीं, मैं तेरे को क्वेश्चन पूछ रहा हूँ. अरे okay. Schwarz reaction. Schwarz reaction. Now this is the very first reaction which we are going to prepare what, beta?
15-20 सेकंड ऐसे ही आने.
अल्काइल. अरे बेटा, इसमें कैसा क्वेश्चन आएगा वो भी मैं सब बता रहा हूँ. पहला खाली एक रिएक्शन का नाम देख लो बस. You just see this. This is the only method which we prepare what, beta? Alkyl fluoride. This is also halogen. Chlorine, bromine, and iodine will be replaced by fluorine. Look, can you see here? Chlorine is replaced by fluorine. Bromine is replaced by halogen is X. Acha, but what reagent we will use here? I can use either. Now look, this is very important. You can either use silver fluoride. What you can use? Or you can use this cobalt fluoride, antimony fluoride, mercurous fluoride. And in all this reaction, what is you are getting? SF. बेटा वो है ना कोई क्रिकेटर स्टेफन फ्लेमिंग, याद रहेगा स्टेफन फ्लेमिंग. तो स्वार्ट्स रिएक्शन से क्या बनेगा? फ्लोराइड. हाँ, तो जो भी है बेटा, स्वार्ट्स जो भी याद रखने का. हाँ, फ्लोराइड बनेगा, अल्काइल. So this is halogen exchange. So now look that we can complete this chart. Now what we did till here. Now what was the last two, beta? Tell me. Finkel and Schwarz. Finkel and clear. And what we use here? Alkyl halide. Both alkyl halide we are using. Are you getting? Now look, I'll show you the flow chart how I have given in the notes. Look here. Look, we did all this preparation. Hello. Look, so chlorine it was UV light, then bromine, ABN. For the iodine, we cannot use direct. So look, we have written what? Oxidizing. Then we did HCl, HBr, and HI from alkene. Now look from alcohol. How many method we did from alcohol? Can you see? Oh baby, HCl, HBr. Whenever we use HBr, we have to write this. Whenever we write HI, we have to write this in situ. Then we did from PCl 5, PCl 3, PBr 3. Okay, P and PBI, PBr 3 and PI2, and then SOCl2, best method. And now, beta, we did this. Hey, when I use this one is which one, beta? Finkel. This one is, and these all three are what? Swarts. देखिए हो गया ना बेटा? All this you get. So this is how. First look, beta. First you will go through the color notes and then this chart you will make, and every day you will go through this chart. On this side, all are, on this right hand side, all are what? Preparation. All are, and on the right hand side, all are the reactions. Chemical property. Okay, so I'm giving you break of 10 minutes only. 10 minutes only. Okay, look, beta, we did preparation of alkyl halides. All method we did. Okay, now look, few textbook question I'm going to solve with you all. Please pay attention here. Textbook if you have with you, or you tell me, okay, if you don't have also, then you pay attention. Page number 231 I'm doing. Okay, 235. What, acha, can you see this question you can do? Which is the best method for alkyl fluoride? SF. अल्काइल फ्लोराइड बोला है. फ्लोराइड एक ही था. स्वार्ट्स रिएक्शन अल्काइल फ्लोराइड, इट इज ओनली स्वार्ट्स. अरे that is some error in the textbook. I have not highlighted. Okay. Now look here. You can do which one on your own. I'll just tell you. Chalo. Page number 232. 232 में ये दो reaction you can do on your own. Whenever I use Ni and this chlorine, so what will get replaced? Arif, just now we did halogen exchange. Halogen exchange will take place. So what I'm going to get here? This will remain as it is. And here what I'm going to get? Instead of chlorine, what will come? That's it. And what will be the IUPAC name for this? हाँ, वो ठीक है ना. ले बस खुश. हाँ, नहीं यार. 1 2 3. 1. अरे 1 को मैंने ऐसा लिख दिया. सॉरी. रोमन आयोडो. 1 iodine. 2 methyl propane. Understood this? Hello, hey baby. Look here. What will happen here? Come on, Navya, you tell me what will happen. Bromine will be replaced by fluorine. Acha, this was which reaction? This was which one, beta? This one. This was Finkelstein. This was Finkelstein. Okay, and this is what, beta? Swarts. Swarts mein what will happen? Bromine will be replaced by, I'm writing here, there is no place. So what will get? Fluorine. And what will get here? SbPr3. Okay, what is the name for this? IUPAC name na, to fluoroethane. What it is? Easy. Okay. ये तो टेक्स्ट का आना चाहिए बेटा. You should know all this. Right? अरे फिंकल में I आता है कि नहीं? तो है chlorine will be replaced by I. Okay, and so only alkyl fluoride के लिए that reagent you will have to remember. Either I could have used AgF, cobalt fluoride, SbF3, right? So look, beta, this organic beta, little bit memorization is required. That is why I'm telling you, prepare a flowchart with your own handwriting and stick it in. And every day you have to see it once. What are you going to do? You have to take it happy. हो गया? Balance. Okay? Yeah. चलो. Balance. Not required, beta. Major, खाली वो main structure है. आपको वो देखना, what they have told, major product only. So that is why I was not writing all this part. Hello. Chalo. Shh. I want you to predict the answer for this. Chalo. Shh. First, you have to see whether it is symmetrical or unsymmetrical. Acha, here it is HBr peroxide. Miranda, beta, please pay attention here. It is unsymmetrical HBr peroxide. So which rule? Markovnikov or anti-Markov? Anti. Anti-Markovnikov says that the negative part of the reagent will go to the anti-Markov. We have to follow reverse. Will go to the carbon having more.
No number of hydrogen.
स्तर पे जाए more. More. So what you are going to get? This will remain as it is. This will become CH2. And this will become CH2. And here what will come? Okay. Write it there. Where is your textbook?
Right.
You have to carry textbook. How many times I have told you all? How many times I have told you have to carry textbook and all? Ziaul Haq, tell me what will be the product here? Here, this one D1. Yeah. Test method. You remember thionyl chloride? H will get replaced. AD. Then
OH.
yeah. So I'm interested only in main product. So main product will be what? Here what will come? Chlorine. And if you want other byproduct, I'll write the other byproduct also. Happy? Acha, but what is this? This is which? What is the name of the product? Cyclohexyl chloride. Yeah, chlorocyclohexane. Okay, this I have not taught you so far. But so now, are you getting what type of question will come? Yeah, tell me you have some questions. Okay, ठीक है ना बेटा, chill. Okay, shh. Have you all understood this? Look, until and unless beta, again for organic, look, physical chemistry, it is very easy. Why? Once you read it, concept, everything is clear. Then once you read it, you will remember it for a longer period of time. But organic chemistry will require frequent revision. That is why I'm telling you, prepare the flowchart. I have already given the flowchart. Every day you'll have to see it at least once, beta. Otherwise, I'll make you write five times reaction. Then only you'll get it. All the reaction which we have done today, you are going to write. I'm not going to give it, make you write 5 times, but write it at least once. Look, organic chemistry, beta, without practice, you will not get it only. Karna beta अच्छे से. I have tried to make it very simple by giving this colorful split form notes also. Okay. Shh. Done beta this. Shall I go to the next part? This all I have not taught you. This also not. Okay. Chalo beta. All this we have not taught you, so I'm not going to do that part. Now we are going to do the reaction. Come on. Now I told you what today one thing. What I told you, beta. If a come on. Hey Ryan, beta, tell me. If a functional group is replaced by another functional group. If a functional group is replaced by another then it is which reaction? Nucleophilic reaction. Look, today only I gave you. Hello. Look here. Whenever a functional group is replaced by new functional group, then it is what? So now we are going to study which reaction? Yeah, Ryan, look here, beta. Okay, let us start. So what you will do, beta, on page number, my colorful notes, I want you to do page number 6. And what heading you will give here, beta? Here already substitution is written, but I want you to write which substitution? Nucleophilic substitution. Nucleophilic. Just write it. Why nucleophilic I have written here? Hey, Dhairya, can you see this? Halogen is replaced by another functional group. Now look, we have prepared alkyl halide. Now we have to study reactions of alkyl halide. We have to study reactions of. So from alkyl halide, we are going to produce new compounds. Okay? Right? Chalo. What dear? What you doing? Okay. Yeah, Miranda, first reaction you see. What is happening here? Have you written first this nucleophilic? What your page number भी नहीं पता है तेरे को? Page number 6. Student, please, in organic chemistry, don't take things lightly. तो रिएक्शन रीड करना ही पड़ेगा बेटा, वरना नहीं आएगा. इट इज ऑर्गेनिक केमिस्ट्री इज द मोस्ट स्कोरिंग ऑल्सो. हाँ, बहुत इजी होता है बेटा. एक बार रिएक्शन तूने याद रखा तो फटाफट हो जाएगा. फिजिकल केमिस्ट्री में यू मे गो रॉन्ग इन कैलकुलेशन दिस एंड दैट, राइट? हियर इट इज वेरी स्ट्रेट फॉरवर्ड. चलो, नाउ फर्स्ट रिएक्शन. व्हाट आई हैव टेकन हियर? कम ऑन Miranda, tell me. This is alkyl halide. I'm taking what? KOH. In ICSE, hello, in your 10th grade, there was one reaction, if you remember, beta. And I've told you, like I generally tell my student, whenever aqueous, S is there na ending mein, so what it will be? Substitution. Whenever you take aqueous, then it will be what? So aqueous, NaOH or KOH I have taken. So what is happening? This X is replaced by whom, beta? OH. So I'm getting alcohol. But I have to take which? NaOH and KOH should be aqueous. If we take beta alcoholic NaOH or KOH. So beta, if you drink alcohol, you get eliminated. So if you take alcoholic, it will be which reaction? Elimination reaction. Which reaction? But we are not going to do, if I take alcoholic, but here we want what? Substitution. So we are going to take aqueous. How to remember? In aqueous ending mein S is there, so it will do substitution. So my halogen is replaced by what? OH. So I'm getting alcohol or not? Tell me. Instead of KOH, I can either use NaOH. So this is beta general reaction, and this is the example here on the right hand side. Can you see? Ethyl bromide, aqueous KOH. So K and Br will get react, and Br is replaced by OH. So can you see functional group is replaced by another functional group? Therefore, it is which reaction? Nucleophilic substitution. Any difficulty till here? Hello? I have taken an example. If I take ethyl bromide and aqueous NaOH, so what I'm going to get? Ethyl alcohol. So this was first nucleophilic substitution. Now, I can either do this way, beta. Look. So, beta, look, listen. Now, we want to do the flow chart. Now, in flow chart, beta, there is no place here, so I'm making a fresh one here. How to do? We are doing reaction of alkyl fluoride. So first what we are doing, beta, look, aisa pura hai. First I used what, beta? NaOH and QH. Both were what, beta? Aqueous. So I got what? Alcohol. Understood? Now I'm going to use, beta, moist silver oxide. Hey, when I say silver oxide, formula is Hg2O. Moist means I'm going to add water to it. Hey, these two will react among themselves and they will generate what? AgOH. So next reaction, what I'm going to do? I'm going to use AgOH. How I got this AgOH? These two react. Are you getting it? So now what will happen is X and Ag will react. So what will happen? OH will come here. So again, it is nucleophilic substitution or not? Tell me. Acha, let me tell you one thing. Since we are doing this reaction, we are also covering alcohol. This will be preparation of alcohol. In alcohol chapter, we'll study preparation of. Once you do this halogen derivative, beta, almost 20 reaction of alcohol we cover in this chapter also. Yeah, all ROH वाला, PCl3 याद आ रहा है, PCl5 उसमें सब भी अल्कोहल के साथ रिएक्ट करते थे ना बेटा, याद आ रहा है कि नहीं? HCl, HBr, HI. Is this clear? So what is the next reaction? Nucleophilic substitution. Hello baby. Hey, listen dear. Moist silver oxide. In exam, you are not supposed to write this. In exam, what is our main reaction? How I got AgOH? These two reacted among themselves. Main reaction is this. Look here. Hey, Udre. Rx plus AgOH. Can you see? So, can you see alcohol has been formed here or not? Functional group is replaced by new functional group. Are you getting it? Now, I am making reaction with potassium cyanide. Potassium means K, cyanide means Cn. So alkyl halide. Look, can you see alkyl halide with potassium cyanide? So what will happen, beta? This K and X will react. What you will get? RCN. Alkyl cyanide. Acha, cyanide IUPAC name is alkane nitrile. What it is? Cyanide group is also called as nitrile. In alkane nitrile, we count all carbon. Count all carbon. So what will be the IUPAC name? All carbon we have to count. So suppose if beta here if I write CH3, so total how many carbon? 1 plus 2. So it will be ethane nitrile. It will be what? Yeah, I'll show you here. Here. Wait, beta. Baby, here, jo. Look here, dear. Iloni. Look. Methyl bromide plus KCN. So this will go. So methyl cyanide is common name. But in IUPAC, I'll count all carbon. How many carbon are here? 2. So ethane. What ethyl? Ethane nitrile. Alkane nitrile, na? IUPAC name. Are you getting it or not? Tell me. Hey, Darsh, beta. Look here. How many carbon? Look, ethyl bromide and KCN. So what do you get? C2H5Cl. Acha, can you see functional group is replaced by new functional group? Therefore, it is which reaction? Nucleophilic substitution. Okay. Acha, how many carbon are there total in this? Total carbon count? 2 plus 1, 3. So 3 means alkane nitrile propane. Are you getting it? Okay. So now if you go in our flowchart, beta, what update we will do in our flowchart? Hey, come on. KCl. So what do you get? RCl. Acha, who was the nucleophile? Halogen nucleophile is replaced by strong nucleophile cyanide. Okay, cyanide. In the previous case, who was the nucleophile? OH. In this, who is the nucleophile? Cyanide. Now, beta, this cyanide is ambidentate. What it is? What, beta? Because in first case, either my carbon can be donor or nitrogen can also be. So it can attack from both the side. Amphibia word सुना है? Amphibia, frog is an amphibia. Okay. It can दोगले किस्म का जो होता है land and water. So cyanide भी दोगले किस्म का. It can sometimes attack from carbon or it can attack sometimes from nitrogen. Whenever it will attack from nitrogen, then it should be medium. Should be what? Covalent compound should be there. What should be there? Okay, covalent compound. And from carbon ion, it will attack when it is an ionic compound. Potassium cyanide is an ionic compound. Potassium cyanide is. But if I take silver cyanide, what I take? तो silver cyanide में covalent character होता है. क्या होता है? So whenever beta silver will be there, it will always attack from nitrogen side. Whenever silver will be there, it will always attack from which end? So if I take instead of KC and if I take silver cyanide, can you see this silver? So what do you think, sir? ये AgX होना चाहिए, RCN बनना चाहिए था ना? नहीं, क्या बन रहा है? RNC. By NC, because silver, first of all, cyanide is what, beta? Ambidentate. It can attack from both. From carbon side, it will attack if I take ionic reagent. Ambidentate nucleophile, na? Ambidentate. Okay. So here, whenever you use silver, beta, it will attack from which side? तो इसको क्या कहेंगे बेटा? Isocyanide. अरे CN is cyanide, NC is isocyanide. Both are functional isomer of each other. Same molecular formula, but different functional group. अरे RCN and RNC दोनों का formula same है कि नहीं? But functional group अलग है. So they are which isomer? Functional. So look here, beta. Hey, look here. Why cyanide attacks through nitrogen when silver salt is used? Are you getting it? Okay. So what update I'll do in my flowchart? Tell me. Hey, what update I'll do in my flowchart? Come on. Hey, if AgCN, if I use, maybe AgCN. So what I'm going to do, write RNC. Hey, can you see functional group is replaced by, in all these cases, functional group is replaced by new functional group or not? Tell me. Yes. Now, beta, two reactions are not there in our notes. Yes. So what I'm going to do, I want you to write this too. पीछे blank जगह है बेटा. अरे पीछे white paper है पूरा. दिख रहा है कि नहीं? Two more reaction I'm giving you. Same nucleophilic only. Hey, look here. RX. I'm going to take first potassium nitrite. What it is, beta? So when I take potassium nitrite and I am going to use silver nitrite. Potassium nitrite and hey beta, whenever silver we use, beta, what we have studied, whenever silver is used, attack will be from what? Nitrogen. But if I normally use potassium nitrite, then I am going to get ONO. What I'm going to get? ONO. अरे हाँ, पोटेशियम नाइट्रेट में, अरे पोटेशियम नाइट्रेट में ऑक्सीजन वाला एंड होता है. ओके, आयनिक कंपाउंड ना, दिस इज पोटेशियम इज आयनिक. Silver will be always what, beta? Attack will be from what? N. Are this is same or not, beta? Okay, what I'm going to get here? Kx. What here I'm going to get? AgX. What is the name of this compound? Alkyl nitrite. Alkyl, and this is known as nitroalkane. Nitroalkane. Now you wonder, sir, why I have not given in your this thing notes, but I want you to write this. I'll show you. Wait, I'll give you time also. I'll show you in the textbook first. Where in textbook? In textbook, beta, all these reaction they have given combined, you'll not understand anything. Look. Yeah. Whatever reaction I have showed you so far in textbook, they have given it directly. Wait, I'll show you where it is nucleophilic substitution. Here. In textbook, it is page number 220. 220. Look beta. A. Alkyl halide NOH or aqueous KOH. Can you see? ROH we got. Then I taught you this one beta. Hey, KCN and AgCN. Can you see? RCN and isocyanide. Right now, which example I gave you, it was this beta. Can you see? Potassium nitrate and silver nitrite. So here you get alkyl nitrite and here you get nitroalkane. Are you getting it? Achha, now you can write. एक मिनट, किधर था अपना, ये था ना. अरे हेलो, yeah, this is alkyl nitrite and this is nitro. You have to just replace in example. What you will replace, beta? This I'll write it as methyl, and this halogen you can take chlorine, bromine, iodine. This nucleophilic substitution I want you to write in that big notes. Don't forget, huh, beta? I'll make you write few reaction in this big notes. Ryan, beta, what happened here? CT करना है बेटा अच्छे से. बेटा, look students, beta, be focused, huh, beta, because this is not like your 8, 9, 10th where you will study for last 1 month and you will score. Especially Meetibai students, remember beta, in your 11th standard they had skipped many things. So and they had given question bank, so you are able to score well. But here it is board pattern beta. So that is why please don't miss any test. Do all the work which I am giving to you regularly and follow my instructions. Then only you will score beta. Board में it is going to be totally different scenario. Clear? Is to our nucleophilic substitution. Whenever silver will be there, beta, it will be attack, and silver wala compound and nitrogen is involved. The attack will be from which end? Nitrogen end. Okay. Chalo, done. Hello dear, done beta. अरे ये पेज नहीं, अलग से लिखना है अपना बड़े वाले नोट्स पे. टेक्स्ट बुक में पेज नंबर पे कहाँ पे दिया है मैं बता देता हूँ. ये देखो, टेक्स्ट बुक से कुछ समझेगा नहीं बेटा. दे हैव रिटन ऐसा बस इतने इतने में खत्म कर दिया ये पूरा. मैंने पूरा आपको ये अलग से इसमें अच्छे से एक्सप्लेन किया है इन माय नोट्स. इफ यू सी हियर, हेलो, look, whatever reaction they have given, they have completed only in one, but I have given very nicely. Look, I have given general reaction and their example. Can you see? Look, I have given example also beta. This is general reaction and these are examples. Now beta, we go to this Williamson synthesis. Williamson. अच्छा, who was, अच्छा मेरे को एक फटाफट बताओ. ए पहले में न्यूक्लियोफाइल कौन है? OH. सेकंड में भी OH. In third it is cyanide. Here it is what beta? Isocyanide. Okay, and right now we did that was nitrite, and then another one it was nitro. Okay, now we are going to do Williamson synthesis. Williamson. उससे पहले आपको बेटा क्या आना चाहिए? Listen. Hey, you know ether. Ether नाम कभी सुना है ऐसा? ether. धैर्य बेटा, ether is a functional group on which both the side we have alkyl group. Both the side we have. अच्छा, in common name how we write? Come on. Hey, if this is CH3 or CH3. Ryan beta, methyl. So it will become what? Dimethyl ether. Dimethyl. Okay. And I can have like this also, beta. CH3O, C2H5. If two are different, then we have to follow which order? Alphabetical order. यहाँ पे कौन है? Ethyl. Here who is there? So what will be the name? Ethyl, methyl, ether. Understood this? Acha, in IUPAC, how do we write, beta? We write this way, beta. Alkoxyalkane. Alkoxy. Yeah, wait, beta. Let me give the logic. Alkane should have more carbon. Alkane should have, and alkoxy should have. Acha, now in this case, look on the left hand side and right hand side. Yahan pe bhi one carbon, so no more or less. So this will be what, beta? Methoxy. And this will be methane. Right, beta? Methoxy, methane. I'm explaining the name. Chalo. Chanel, beta. Tell me, beta. What is there, beta? On this side, how many carbon? 1. On this side. So who is more carbon? 2. So it will become your alkane. More carbon, alkane. 2 carbon wala alkane ka name is what? Ethane. And this will become your alkoxy. So it will be methoxy ethane. Have you understood this? Now I'll tell you very simple logic, beta. Listen. We are studying reaction of alkyl halide. I am going to make it react with what, beta? We are going to make it react with RONA. RO? ये RONA ऐसे बनता नहीं है, रेडीमेड नहीं होता. We prepare it. How I am going to prepare this, beta? I am going to take alcohol and I am going to make it react with sodium. Hey, can sodium replace hydrogen in reactivity series? Can you see hydrogen is below? Achha, now what will happen here? Look here. Rubin, beta, look here. This Na and X will go. So what will get, beta? Tell me. R you will get, and what will happen? OR. Achha, now can you see what was your here functional group? Halogen. It has been replaced by new functional group or not? Therefore, it is nucleo. In this reaction, you get ether. Therefore, the name is what, beta? Etherification. And hey, who studied this, beta? Williamson. Therefore, it is known as Williamson synthesis or etherification. Have you all understood this?
Yeah.
Chalo, beta, let us do. So, beta, first step in exam, you are not expected to write this left hand side. In left hand side, I have told you how do you get this RONA, means sodium alkoxide. Can sodium displace hydrogen or not? Tell me.
Yeah.
But we are not interested in this left hand side. This is our main reaction. This is our main reaction on the right hand side. Look. So how I got this? This is what I showed on the left hand side. I am going to make it react with alkyl halide. So what I am going to get? Can you see? And you get RO. Acha, if this is ethyl and this is also ethyl, then what do you get? Dimethyl ether or ethoxy. But if I use two different, then same. If on the both the side you have same R, we call it as, if both are same, beta, we call it as simple ether. But if both I want different, then it will be what, beta? Mixed. Can you see here? This and this are same or different? So I get what? Ethyl, methyl. How you got this name? Methoxyalkane. More carbon will be your alkane. Less carbon will be your alkoxy. Any difficulty till here? Hello, bolo na. So what update will do in our flowchart? Tell me. Come on.
Williams.
हाँ, कहाँ गया? नहीं उससे पहले चलो. KNO2 होता तो क्या मिलता था? RONO. Then AgNO2 होता तो क्या मिलता था? बोलो. RNO2. Right? Then beta Williamson synthesis में we used to take RONA. Means, so how do you get RO? Clear hai? Now since there is no place, I am writing here a further reaction. Chalega na beta? Okay. Below there is no place. Now I am going to take alkyl halide and I am going to take ammonia. Can I write ammonia this way? NH3, can I write it? So this H and X will go and what will come here? NH. This is known as amine. This is known as, so next reaction in here. Now beta, one more important thing I am just telling you right now. Whenever we do this, your RONA should be bigger. RONA should be bigger. Means it should have more carbon. It should have more carbon. Always remember. Then only ether will be formed. Otherwise, ether will not form. That we are going to study in ether chapter. I'll teach you that in ether chapter in detail. But just I'm making you write this. Why? Your Rona should be bigger. Why? Because if you means your sodium alkoxide part should be bigger. If you take it small, then alkene will be formed. Then what will be formed? We won't get ether. That we are going to study. Don't worry. Okay. Chalo. Now next reaction is what beta? Nucleophilic only I am doing. Nucleophilic only I am going doing. Yeah. Yeah. You can leave beta. ठीक है? You can leave. Yeah. Shut up. मेरे को ये करने दो ना बेटा. हो गया बेटा. एकदम छोटा सा पार्ट ही है. Please बेटा. This page बस फटाक से हो जाएगा. Only this page I'm doing. नहीं. वो मैं ये पेज करवाने दो मुझे बस. ठीक है ना? Not अरे these two. Only these two nucleophilic I am completing. Hey, I'm taking what? Ammonia. Now tell me, beta, halogen is replaced by what? Amine or not? Tell me.
Yes.
Acha, here I have taken excess, huh, beta? This is very important. Why? Because if I won't take excess, then I will get mixture. I'll get what? So now this is Hoffman's ammonolysis. Why? Because Hoffman studies this reaction if we get amines by adding ammonia. Now, what update we'll do in our flowchart? Tell me. Look, there was no place. So look, Rx per. So you get amine, alkane, amine. We get what? Alkane, amine. Now, last nucleophilic substitution reaction. Last nucleophilic is what, beta? Silver salt of carboxylic acid. Silver salt of carboxylic acid. Look here. Hey, this is what, beta? Acid or not? Tell me.
Yeah.
Okay. Now, if I replace this H from here, so what I'll write? If I write here silver, so it becomes silver salt of carboxylic acid or not? We are going to study reaction with alkyl halide. Alkyl halide, can I write it ulta also na? Rx. What will happen, beta? This AgNX will go. And what you are going to get? नहीं, हाँ, AgX गया. Main AgX में interest नहीं है हमको. Main इसमें interest है. हाँ, and this is what, beta? Do you know, beta? This is which functional group? Esters. अच्छा, ester में we write this first. हाँ, fruity smell. हाँ, very good, beta. ये alkyl part we write first, and this is your remaining alkanoid. Wait. So, acha, now tell me, the functional group is replaced by new functional group or not? Tell me. So we are studying which reaction? Nucleophilic substitution reaction. Which reaction we are studying? Nucleophilic substitution reaction. Okay, so look, let us study the reaction. Can you see, beta, we are doing alkyl halide. This is silver salt of carboxylic. I have taken one example. Come on, tell me, beta, this is silver. And how many carbon were here total? 3. So it is a derivative of propionic acid. So silver propanoate. This is ethyl bromide. So Ag and Br will go, ethyl will come here. So whatever is with O, the group which is with O, we write its name first. So this is what, beta? Ethyl. And this is what? Propanoate. Are you getting it? That is common name में propionate बोलते हैं. IUPAC में propanoate. Look, if I take this example, look here. Who is along with O? Methyl. So I have written methyl. And how many carbon are here remaining? 2. Acetic acid का derivative. So methyl acetate. Are you getting it? Hello. So what will be the update in our last nucleophilic substitution? Tell me. Where it is? No, alkyl amine हो गया बेटा. And then what? Alkyl halide with what? Yeah, ester, like RCO. So what you will get, beta? RC double bond O. So we are done with all the nucleophilic substitution. Beta, I have given this flowchart. Look, I'll show you. Wait. Beta, देख ले. नहीं पढ़ा रहा हूँ. देखोगे खाली at least. Look, all of you look here. अरे बेटा, this is the way you. 2 minutes, बेटा. तो इसको जाने का, उसको गिटार जाने का बेटा. Look, on this side, all this side is preparation we did today. Left hand side was our preparation or not? Now right hand side, beta, I have done, we did all this. Can you see? अरे देखना अल्कोहल बना ना EGX, NOx, KCN, IGCN. यहाँ पे क्या मिसिंग था? NO2 और AgNO2. KNO2 और वो मिसिंग है बेटा. Esterification. Can you see this? I have not done these three reactions so far. These three reactions I am going to do in the next class on Saturday. Please beta, read and come. I am going to do lot of conversions on Saturday. And that is very, very important. Conversions we have to do. Saturday, beta. Look, beta. I'll give you time 1 week extra for solution and colligative. Theory ka test. But CET test I'm going to take. That will be in this vacation anytime you give. I give you 4 days ka time. Okay? But please, I want all of you to come on Saturday. Listen. ये online student come offline on Saturday because I am going to teach you conversion and please beta read this and come.
Sir, we don't have solutions test on
Yeah, tell me.
Saturday.
Huh?
We don't have solutions test on Saturday.
No, I'm not taking solution. I'm postponing that reason because I want to complete this because I'm giving vacation for 1 week. Okay? Right? I'm giving you right now. Chalo then, bye-bye everybody. Hey, tu test leke ja.
Bye, sir. Thank you.